Hello, so let's start with this problem. The tallest spot on Earth is Mount Everest, which is 8850 meter above sea level. If the radius of Earth to sea level is 6358 kilometer, how much does the gravitational field strength change between the sea level value at that location and top of the Mount Everest? So for this, what is required in this question is how much does the gravitational field strength change? So the main thing that we need to find is this delta G. And the delta G, we need to find the G of at the surface minus the G at the Everest. So this is the equation that we need to solve in this problem. One more thing, because from our physics principle, we know the relation of this G, the acceleration due to gravity, is equals to capital G ME divided by RE square. So this is the relation of small g with capital G, the gravitational constant, and mass of Earth, the radius of Earth. So these all are very big numbers. And for surface, so this is the value on the surface. If we want to find the value for this Everest, then this relation is gonna be GME divided by RE plus H square. So the height that is above the sea level, so it's gonna add up this height too in this. Now one important thing that if we are going to put these big numbers, the capital G M E, then this relation will be very difficult to plug in these numbers and find the answer for this question. So what we are going to do, we are going to find the ratio of G of E over G of surface. So this is going to be our capital G M E divided by RE square. This whole thing GME divided by RE plus H square. So this thing will cut, this one will cut with this, and now we will be left with the relation that G of E over G of surface is equals to G of surface. This will be equals to RE over RE plus H and the square of this. So now from this we can say that the GE we can substitute in terms of G of surface, and that's gonna be RE divided by RE plus square of this and multiply by G of surface. So now we have this value of GE in terms of G surface. So we are gonna plug this in this equation. So now our equation delta G will be equals to G surface minus G of E. This will become G surface minus RE over RE plus square of this whole thing and G of surface. We're gonna take G of surface value outside from the equation, and this whole equation will be RE plus H and square of this. So now we have our values that the R of E is given to us. So the R of E value is 6358 kilometers, and the H value is 8850 meters. So we're going to make sure that we'll convert kilometers to meters in this equation. So the delta G will be, G surface is our 9.8 meter per second square, then 1 minus RE is 6358 kilometer, and that means 10 raised to the power 3. This is 6358 10 raised to the power 3 plus 8850, square of this whole equation and this. And when you will calculate this whole equation, the delta G will come out to be 0.0273 newtons per kilogram. So this is how you're gonna solve this question. Thank you.